Hello, welcome back to the stream. I'm Jun Chan, and today we're, for the 20th time, probably more in fact, doing some Purescript. That's for definitely for more than the 20th time, doing some graphs and some graph Comonads. And yeah, still in the algebraic graph library data library. And well, I did put a clock on myself, not just for right now for in an hour, but also in terms of doing only 20 streams on the Purescript graph Comonads. So I mean, I might come back to it, and maybe I'll go back to rotate between topics as I was doing before. But I'm going to just try and wrap it up. So that means at least pushing what I have right now into some kind of PR. It's going to be a massive one though, but not great to, maybe we can do it in several steps. So let's see. We were writing an arbitrary instance for pointed graphs. So should I do that, or should I start packaging? I think maybe I should start packaging. So what do we have? We have a bunch of uncommitted stuff. And so graphs, let's see. Shell.next, I didn't have any of that before. Yeah, I suppose I can submit that maybe. Let's see, how is it done in Purescript Alga so far? Yeah, it was packages and Spago. So packages and Spago will be fine. I just, well, yeah, I just need to make sure whether I'm about whether I'm using all of the things or not. And I think already partial and something else was not used, if I'm remembering correctly. Okay, I'm going to need to allow this to compile by going to the tests and for now commenting that out. Yeah, so I think it was partial and something else. I'm going to do my little housekeeping, and yeah, contravariant apparently. 1111. Okay, and I'll write here that we are, before doing an arbitrary instance for pointed graph, we did fix that actually, right? I just simply didn't. Whoopsie. What? Yeah, okay. I didn't save it. It's fine. Let's actually copy this and yeah, so today we are pushing changes to a PR. And right, so we remove contravariant and partial. And we do check whether they were in the diff or not. Contravariant used to be there, and we don't have it anymore. Wonder why. So it succeeds without errors, and let's see. We had, I think, a PR with undirected graphs. So ideally, we just okay. So this one was open. So maybe we can target the undirected branch. Yeah, we are in the undirected right now, and I said here that it was at least building, and I added contravariant actually. So we don't need a contravariant anymore. I'm not sure why I added contravariant, but Plus, I started working on new undirected things like the adjacency map and whatnot. Okay, so this didn't get much attention, which is fine. But it's just, I think if I could make just 2 PRs, I think that'd be good. So if I can push the remaining of the undirected stuff, I have RemoveEdge commented. Is that a fact? I do. Why would I have RemoveEdge commented? I suppose I hadn't finished it. Well, that's a bit sloppy. I used to do that's a context. Yeah, it's very sloppy. Okay, well, let's see if we can fix that quickly or not. We don't have tests for it, but let's see. Show me RemoveEdge again. Okay, so it looks like it would sort of compile, but it needs a context that we don't have here, and that's because it's been probably, yeah. And right, so so all that stuff below we are kind of moving elsewhere, so we can not put it here, but yes, we will need an undirected version of all of that stuff. It is not that simple. And so it would mean that we can't remove edges for now. It is not very satisfying. But if that's where we have, that's where we have. So maybe we just make remove edges as a to-do. Yeah, I think that's what we need to do. Although we could actually append the inputs and the outputs. Could say, could we just do that? If we did, we have a problem with this type, which makes sense. We need to be edges, and then it's unclear how we would parse all of this. And okay, now I'm just wondering whether actually it would work even if I had inputs and outputs, which we would then need to change later, but it might be inefficient, but maybe it will work. Inputs, undirected version. So how would that work? Yeah, in appearance it would work. How would we know whether it actually works? Yeah, there's a bunch of tests that we would need to submit in chunks here, which is fine. But let's try to remove a vertex and convince ourselves that it works in the way we intend, or remove an edge rather. So that's actually Boolean. So I'm not sure. Oh yeah, I use AMU now for this. And show. Not very clean. Also, yeah, but correct in appearance at least. So let's try and remove an edge from that. It remove edges from a simple Boolean graph. Let's remove the false true edge here. Actually, let's remove the false false edge. I think let's remove both. We want to remove actually UG edge true false, and so if I remove true false, then this should be this. Actually, let me first copy this. I think I want it 3 times. So I said if I remove true false, it should be this. If I remove false true, it should be the same thing. And if I remove false false, it should be this. And we don't import RemoveEdge from, well, actually, what's going on? We should be exporting it now. UG dot. And maybe we don't have the Typewrite. Takes 2 A's, and okay, yes, indeed, we do not have the Typewrite. So good. So we don't need that edge here. We just need true, false, blah, and then false, true, blah, and false, false, blah. And maybe an apply here. No. Oh, yeah, we don't have to adjacency map here. If we do, we have it. Yeah, we have it here. But I dislike having this would probably work fine. Yeah, maybe. Right, it wouldn't because of this show here. Yeah, I don't know that I want to have this complex but let's at least try and see whether it works. But I now I feel a little bit self-conscious about how ugly this looks. Oh well. Okay. All right, it compiles. We don't import Comonads. We could, but we don't. And two of the tests passed, but not the second one, interestingly enough. And let's see. So removing false true, I would expect should give us exactly the same as removing true false, but it doesn't. Apparently removing so therefore we are broken. That's good. So I mean it's good because it means that differentiating inputs from outputs doesn't work the way that we want. And so here we say it's undirected. There's nothing about a part of wrapper that tells us that it is. Nothing really inside the graph itself. So maybe that's not the best way to do it. Actually, maybe you should be UMT, uvertex, uoverlay, uconnect. Which is maybe a smell from having had to do this. I mean, we are following what Arga does. So what does Arga do, by the way, for RemoveEdge? Let's go find out. Undirected. It coerces graph RemoveEdge, removing both edges of both directions. All right, that's kind of cool, I suppose. So maybe we don't need context and so on. And we try that. We try to, so we have a S and a T and a UGG, and we can maybe G dot RemoveEdge STG and G dot remove actually edge TS, and then apply that to G and put a UG in front. And we need to be doing probably, well, if we point full, then we can just do this. Does this fix this test, therefore giving us 55 passing tests? It does. Good. I mean, I don't feel very comfortable about the rest, so I think I can't post this to this PR, but I should just add to the description that kind of a to-do here. Write tests for undirected for each undirected module functions, import docs from Alga. So last time we did see that in some conversation around Alga, there was this possibility to, instead of using undirected, use a undirected adjacency map. And here, yes. But to do that, we should really switch to. So that's exactly the one. And we'll copy the link. And following this comment from Alga. Right. Yeah, that should be the one. And this would be implement well, what we started implementing, which is this guy, right? And that's sort of done, but oh hey, Optical, thanks for the raid. That's really appreciated, man. How's life? So you've been streaming pretty regularly lately. That's nice. And I've decided that 20 streams on Purescript Graph Comonads was enough, especially because I've been a bad June, and I haven't been pushing to the library that I've been writing code for in quite a while. So I'm trying to package some branches and push that push upstream with some comments and so on, so that I can start maybe doing other things that my Graph Comonads for a bit, take a tiny break. Okay, so where was I? Right, so what do I use from the undirected adjacency map that I created here? Well, AM is AM a constructor from undirected here? Hold on, right? I am in yes, okay. I'm in the wrong place here. But I do want to check whether AM is the constructor for indirected. Yes, it is. Okay, it's the new type that wraps the map. Okay, that's fine. However, here, do I import adjacency map undirected? I do. And so there's a bunch of stuff I need to check here. I do import it as AM, and then how do I use AM for things like edge counts? So I have no idea if edge counts are actually meaningful here, and there's a good chance they are not. So let's write a little test for that. Undirected graph boolean, it counts edges for a simple boolean graph. And so if we say, let's see, UG graph, yeah, that's a graph like another, right? And this one has one bidirectional edge and then another bidirectional edge Is it another? Yes, because now this connects true to false, and this, in addition to connecting true to false again, which is a no-op, it's also going to connect false to itself. So there should be two. What am I doing? There should be two edges. Is that going to be counting correctly? Well, it might, especially if I add edge count here. Then it would be maybe the right type. Yes. And let's see if the test pass. Hey, trying to stream every day if you can. That's nice. I think the fact that I didn't hear you means that my chatty is not well, or maybe I'm not hearing things correctly. That's awesome. Every day is a good rhythm. You know, I was doing every day for like for the first 2 months, and it was a bit too much, especially with a day job. Yeah, I'm actually looking forward to my little vacation coming up next week, and I won't be streaming, and yeah, that's going to be nice. Not the not streaming part, just the yes, so it fails. The vacation is going to be nice. Okay, so edge count in undirected adjacency map is wrong because it's the size of the set, and if it's the size of the set, right, it's the size okay, 1 second. The size of the set inside the map. Okay, hold on, I need to look at this again. Stream before work for about an hour. Oh, that's nice. Yeah. Yeah, before work, are you on a US work schedule? Because I think I've seen you stream like around the middle of the day for me in Europe. So that's yeah, that's an interesting rhythm. I imagine, yeah, that the momentum of doing your own thing and like before going to work actually puts your brain in gear. That must be quite nice. That's something worth giving a shot. I'm not a morning person though, but that could be a nice thing. Hey, Jappy, how's it going? Hello. Were you raiding together with Caratical? I'm glad that we have some new viewers. What am I doing here? (12:30 to 2 p.m.) Nice. Yeah, that's a nice rhythm. But you're based? Are you based in the US? Or maybe Boston? No. Yeah. So yeah, that is a morning thing for you. You're from Dutchland, so Netherlands, which is technically, if I understand correctly, not exactly the same country. Yeah. I don't know. Maybe you will, wake me up. Hey, maybe just James. You're also from there? That's nice. Maybe just we can feel the functional programming power. That's good. Hey, it's good to meet you. Okay, yeah, as I was saying, I'm trying to wrap up some of the, like, I don't know, like maybe 10-15 sessions that I've been doing on the Purescript algebraic graph library. That's a port of the Haskell algebraic graph library, Alga. And I've been been a bad person. You know, I've been committing and no, I haven't been committing actually. I've just been writing code and not committing. I've been writing tests though, but I haven't been pushing to GitHub or anything like that. So I'm trying to package that because I've told myself that I would only do 20 streams on Purescript graph Comonads before actually starting to do a little bit of something else, because that's a lot, 20 things on the same subject. I mean, I'm slow, but writing tests, I know, right? I mean, I'm not so proud of my tests, but you know, I'm starting a new job very soon actually, and I'm going to be working with a team that's actually really good doing tests in Haskell. And so I'm totally looking forward to that. That's part of a skill set that I don't think I have, and you can be really good. But I'm happy I did property tests actually for maybe only the second or third time, certainly the first time in Purescript and for a library. So that's nice. Thanks. Yeah. So, and that's actually what I'm trying to do, you know, like my tests are telling me 3 is different from 2, and I have to believe this. I think they're correct. Look for properties. Difficult but worth it. That's super worth it. Yeah. And it actually, I was quite happy with how it turned out. It is really neat. Like for instance, the transpose of is identity for a simple Boolean graph. I don't know that that's, is that, well, that maybe is not the simplest one. What else do I have? Quick check. Structural equality implies equality. That was a fun one. I had to write imply in terms of a Boolean. Also get to use this fancy little combinator from the Purescript quick check library, which allows you to write your own error messages and show the variables that count, which is quite useful when you're trying to do equalities. What else did I do with quick check? Symmetric closure of itself for a simple Boolean graph, for an undirected graph. So a undirected graph is the symmetric closure of itself, because symmetric closure is applying the graph to itself after reversing all the edges, and reversing all the edges of an undirected graph is an OOP. So that passes, but arguably, maybe there shouldn't be such a thing as a symmetric closure for an undirected graph. I'm gonna write this as a comment because I think that might be true. Should there even be a symmetric closure for undirected adjacency maps? Sounds like maybe they shouldn't, but I still have a test for it. And a property test too, so that's nice. And then yeah, because what I wanted to do was to do a test for Comonad laws with a property test, and I did get there. Actually, that I almost got there. Actually, that's part of the things that I came up with this pointed graph concept. I mean, I didn't come up with it, but it's this idea of a graph where there's a specific node that's pointed at, and that can be the candidate for extract if you're writing Comonad. And so I have a failing test that's just one of my examples, and it's clearly failing in pretty stupid ways. But yeah, I was in the process of actually writing an arbitrary instance for graphs in general, and then pointed graph specifically, so that I could write a quick check law that would give me like a more shrunk example of what's wrong with my Comonad law, so that I could troubleshoot it. I mean, I could have started troubleshooting it manually, but I thought there was this little angel on my shoulder that told me that I should write a quick check properties instead. And Yeah, so that's some of the stuff that I've been up to, and right now I was trying to see, yeah, how bad some of my undirected graph stuff was, and yeah, well, I wasn't counting edges properly. That's what I was not doing properly. So edge count is from here, and it's using the adjacency map from the undirected module, which I created. And I'm doing that, I'm actually departing from the Haskell Arga implementation, but only temporarily, because Andrei Markov himself says add a to-do that we should really switch to algebra graph adjacency map undirected at some point in the future. So it just hasn't been done in the Haskell library, but I'm doing it in the Purescript library, and I will probably also submit a PR to Arga once I'm done. But things should be way better tested before I do that. And so right now, AM edge count is not working. To adjacency map should be the right one, but when I do edge count here, I'm unwrapping, and then I'm mapping size. I'm mapping set size onto the adjacency map. So I unwrap, so I'm now in the map, and then I map set size, so I'm actually adding the size of all the sets. Right. I mean, I'm adding it because I then fold sum, which uses the sum-mirroring sum, actually. I see. Hold on, but the sum-mirroring sum is add, actually. I see. So fold.sum, yeah, actually requires a sum-mirroring, and we'll use the add. Why isn't it just using the monoid or semi-group instance? We don't have a semi-group instance for this. I see. Okay. And map set size. Okay. So it's true that in my test, which edge counts, here I have a graph with an edge from true to false, and then another edge from true to false, but that's the same edge, and then an edge from false to false. And so I'm assuming that I have two edges, but what? But let's see what the adjacency map looks like. Well, we know the adjacency map is going to look like something like this, actually exactly this. The adjacency map is, or the adjacency list of the adjacency map is a tuple of false, true, and a tuple of true and false. And so I suppose maybe we need to simplify it. Is that what's happening? I do want to check whether simplifying does what I expect it does here. No, it doesn't. Simplification does nothing. Okay, let's look. So it's possible that my undirected, I simply didn't have enough love at all, and that it's quite wrong. So let's look at connect. Connect is just gconnect. Yeah, I mean, that makes sense. My graph itself doesn't have any notion of the semantic of directed or undirected. What I was expecting was that my adjacency map would, but I mean, of course, it means that I need to surface things in the undirected module properly, but, and yeah, I'm assuming this is true because connect is mul. But note that it's not what I'm doing here. I'm not, and that might be where I fail. That here, for instance, when I connect, well, here when I connect, I just apply the constructor. But here, I do the same thing actually. I just apply the underlying graph constructor, but maybe that's not what I should do. Maybe what I should do is call the underlying, well, there's no real underlying adjacency map though, is the problem. So yeah, the question is, when do I convert to an adjacency map? And any read function is going to need to pass through that if that's the representation I have. And well, it's going to be very inefficient, but let's try and make it correct first. So there is an edge count here. And in fact, yes, edge count of undirected calls edge count of the adjacency map. And that's fine. But it means that actually two adjacency maps should solve the problem. It's just maybe that my two adjacency map is not correct. And well, it looks like it would be correct because it would use the adjacency maps connect, which I would expect would use the multiply, except if there was some mistake in how the how 4G was implemented here. 4G, oh, what's going on there? Connection focus was not used. Okay, that's fine. 4G. I mean, so the functions are in the right order, but now I'm wondering whether, so this will unpack my new type, get a connect and apply the connect function to the recursive application of the graphs. And if my C, which is my connect folder, my connector in my 4G, is am.connect, then that should be mul. And if it is mul, then okay, hold on. Mul, is it really mul imported from the internal module? Yeah, it's no, hold on. Yeah, it has to be. It is mul from the Symmetric instance. So you're just calling, but you're not even saying that you have a Symmetric constraint here. Where are you invoking mul from then? Just because it's an adjacency map, and this is the internal adjacency map, and does the internal adjacency map have some constraint? It doesn't. Yeah, no, I suppose it's just the mere fact that it's an adjacency map, we get the Symmetric instance in scope, and we can use mul. Don't know what I'm thinking. Okay. But then this thing shouldn't this thing that I added solve our problem? What this thing does is that it adds, when doing the connect, let's try to unit test this, I suppose. Adjacency map undirected. Internal. I think I want to connect. Yes, let's unit test this. Adjacency map. Adjacency map undirected. Connects. Simple AMs. And we'll do a connect of what? Well, we want to do some vertices probably, so I suppose just connect am.vertex true and am.vertex false, and that should be equal to I think we can just show that, and make this be, I think, just tuple true connected to false, and what I'm expecting is, I suppose, tuple false connected to true, because that's what my reverse multiplication does, which shouldn't be the case with the regular adjacency map. So let's also write this here, and this should be, in this case, true is the only thing that's connected to false. False is not connected to anything. Like so. Let's try that. And that should be AMU here, if I am to test the right thing. And okay, so simple AM, true, false, false, blah. So it's just the wrong order, but it's the right content. And in this case, what's it gonna be? The AMU. False blah. False blah. Ah, okay. It's just spaces and parentheses. So maybe I was wrong with, I think I was actually probably wrong to try to do this with a show instance. I think that's probably just a tiny bit nonsensical. So let's do it like so instead. And this way we can actually probably even get rid of some of the parents. And then we can do the same thing here, but put true here. And how do I do this elsewhere? From array. I need to also from array the list, which is not very comfortable. Plus my mouse is, I don't know what's up with my mouse. It sucks. From array. Is that right? It is. And so just need true here, right? Oh, haven't removed the show. And if this passes, I'll go get myself some water. And it does pass. I'll be right back. Hydration as the reward for passing tests. I don't recommend it. That's it's not good. Okay, so then of course, if my graphs have an adjacency list when they connect. Okay, first of all, I think there's still something missing for me to understand this. Another simple AM. I need to take my simple Boolean graph and transform it into an AM and undirected graph Boolean. Count edges, this guy. So edge true false connected to false. That's the one. So edge true false connected to false. And what do I think that should be? Well, I kind of want to see also what it's going to be for non-undirected one first. So for non-undirected one, it should be true connected to false, and then false connected to itself. And then false not connected to true backwards. However, for an undirected graph, then false will be connected to true as well as itself. And true will be connected to false, but not to itself. And so that means, does this mean that there's 3 edges? No, because false true is the same as true false, right? Huh. So how are we going to eliminate those? Okay, let's check these assumptions first. Undirected, false true, yes, it's just an ordering matter. True false. Yes. Yes, this does pass. So indeed, like the count, my current algorithm to count edges is the sum of edges here. So it's 1, 2, 3. But I mean, that's fine for a number of things, but obviously it's not good for counting edges. I mean, whether it's fine for a number of things is actually also a statement that I'm not willing to bet too much on. I think I should use a formatter. There is a Purescript formatter, by the way, but I haven't activated it. Okay, that's a tiny rabbit hole, but what is it? Purescript tidy, maybe? Yes. And it's supposed to be just this. Purescript IDE as a built-in formatter. So it would I would need to have PureStyD installed in my shell. Let's see whether Justin has included this in his Easy Purescript Nix. He has. Wonderful. So we don't just easy ps Spago, I suppose we easy ps tidy. Yes, PureStyD. The shell now. Go back into it. That's more things than I would have expected, especially with the pinned. Maybe it's just a dependency to tidy. Don't know, that's a lot of things, but maybe it's just a dependency to tidy. Okay, and then I add this to my IDE. In the formatter. Oh, there is there's supposed to be a formatter there. Oh, well, that's my time actually. Damn, I've done nothing apart from going into a little rabbit hole. Okay, well, Seems like it might be working, the rabbit hole. Let's check it. Maybe I'll need to, how about this? Is it going to format? Well, I don't have formatting on. I might need to reload. Environmental.nix, formatting, boom. It doesn't format. Format. I want Purdy again. Well, I thought maybe I haven't saved. I have saved. Path to Purdy. Oh, there's a Purdy extension. Okay, maybe I need to remove the Purdy extension. This would Purdy. Uninstall. Reload. Format document. Yeah, that's actually, I think I saw some formatting right there. I did, but do we have some parameters? Maybe not. Do I just need to well, we have a formatter. It's not exactly doing what I would want for now, but okay, maybe we need to try another one. Okay, I do want to push something. It's a work in progress, but it's fine. So non-empty and set monad. I needed that for what? Why did I need my set monad? I forgot. It was for the it was for an instance for non-empty graphs. Yes. So do I add the non-empty graph here? I don't think I should add the non-empty graphs. So let's not commit that hunk. Here, quick check, we do want. So come on in, pure quick check. Expect quick check, we want. Come on in. And gen, we want. Yeah, we had to use gen, I think. So come in. Travariant, that's fine. Cannot be there. Class, not yet. Gen graph and focus. Yes, I think we do want you. Actually, yeah, we have an extend instance for graphs, which is just a base class for the Comonad instance. That's nice. And the gen instance. That feels a bit like that deserves its own commit, really. Okay, So add quick check. That'll be one. And then here we are adding, yeah, we're adding a gen instance. We're actually also adding a show instance. I can remove that. I suppose I can remove that. It's internal documentation. So what? Add instant. Add add gen arbitrary instance. Add show arbitrary and extend methods. Yeah. Okay. Instances, not methods. That sounds good. Who's that guy? Algebra.graph internal. That does seem important. We added some back and forth between lists here. Yeah, why not? We can add that. Okay, add to unfoldable from unfoldable. To unfoldable from unfoldable. Go. Hasn't saved changes. It does. Did I do something stupid here? Don't think so. Okay, go. What else? Label graphs. We haven't really gotten started on that. Non-empty graph, I'm not going to commit. Undirected. Well, that's part of the main thing. So, well, we have show and arbitrary instances. We have some fixes. And we've removed some under. Okay. So let's do those in 2 commits. Add show and arbitrary instances, and the rest, which is fix RemoveEdge. Except we know also edge count is wrong, so we're going to just add fix me. And that's you, right? No, that's you. No, you. And yeah, we say we fixed RemoveEdge here. Okay, fix RemoveEdge work in progress edge count. Okay, and what do we have here? We started with an undirected adjacency map. So I'll add that. And I'll also add the internal one, which is this guy. And what? Non-empty, we don't want yet. These other guys, we're fine. Maybe adjacency map internal has a show instance. Okay, that we'll want. Okay, but these are the ones that are important for now. Add undirected adjacency map. I'll say work in progress here. Add undirected adjacency map. And you know what? I'm going to actually tag the Aga thing. And going to tag this comment. See, boom. Okay. And then that's just a show instance, right? So that's fine. Add a show instance. And then we have our tests. And our tests, it's not going to be super easy to figure out which ones are using which, but we'll try. So we're not doing any non-empty stuff. We are doing the graphs. We are doing the adjacency map, both directed and undirected, but we're not doing the class. So we won't add the class. We're doing the arbitrary. And okay, fine. We can make the imports implicit. And also, yeah, okay, fine. Add all suggestions. So none of those. Control Comonad, actually extend is going to be needed. So let's also state that guy. Maybe, I suppose, maybe. Tuple, let's have you. Log show, why not? And then the spec thing is you're going. Those are not. These, yes. And adjacency map of these guys, yes. Transpose should also be fine. Go. And you too. And what's that? Directed version of the example graph, blah blah blah. Yeah. Equalities, that should actually pass. Simplifying graphs, it should too. Let's actually do this now. Simplifying graphs, I was wondering. Yes, I believe so. Context of graph, no, it shouldn't, because that's for empty graph. No, that's not actual empty graphs. Yeah, I think those are fine to have. Yes, it's just the one below that we don't want. The context of non-empty graphs, that's not for now. Undirected graph booleans, yes. And example from Comonad of graph decomposition, overlay, that's fine. And describe algebra graph.class. No, we're not doing that. Comonad focus graph, we're not doing that. Extend graph, we are. So we do have an extend instance, and Comonad of the other thing, not yet. And examples. Bah, no need. Okay, so that should be it. More tests, some laws, and then I'll stash status first, but yeah, I think that's right. False should be correct. Non-empty set monad, contravariant, blah. I think so. So I'll stash, and then I'll try and build, and actually I'll try and test. I think I needed to stash -u. Compiles. And then what? Then write test for, like, for instance, fix edge count, and well, yeah, I can indent that, I suppose. Update. Here are some things to continue working on before merging. Okay, let's update that. Where are we? Yeah, that's good. That's exactly what I want. It compiles. There's warnings, but that's fine. And my edge count is wrong, so push. Actually, is this it? I think I have it in a fork. Yes, git push fork. And there's stuff. Excellent. Well, that's it for now. I'll just stash pop just so that I can continue this some other time. Actually, I also check out. I'm going to push this somewhere else. I'll check out more graphs, and I'll push this to my fork at least. And you know what? Well, actually, I haven't even committed things. And I'll just add everything. Yeah. Work in progress. And push this. And what's going on here? Not happy. Get more graph pull request, more graph, and I'll make this draft. Working on non-empty graphs and pointed graphs. To develop Comonad instances. That's it. There's a bunch of stuff. Yes. And I'm going to say that I want to merge this not on this, but on Undirected. So I suppose I really wanted to commit it to my own thingy. Can I do this? No. Okay, I'll do. If I do this, yes, then I can say this onto Undirected, and I can actually leave Arga alone. Maybe that's better. Yeah, hold on. Let me work in progress. Blah. Don't want to do that. Blah. Okay. Okay, don't know how to copy paste. I'll create a draft pull request. That's on my own thing, and then I'll just close it. And that should be less things. Well, I committed the world, but it's fine. At least it's now in the open. And yeah, that's where I wanted to be at this 20th stream, after doing a bunch of stuff and having like lots to do. But I can say that I pushed those changes to a PR. And so next time, well, next time we work on graph Comonads, we'll go back to pointed graphs and whatnot, but I'm just going to rotate. Next time, I don't know what I'm going to be doing. I might be back doing a little bit of Haskell, because I haven't done Haskell on stream for about 20 streams. So it'd be nice to do that, I think. But for now, that'll be it. I'll be back maybe on Saturday, and maybe a further time on Tuesday, and after that I'm off for probably about a month. And yeah, so see you next time. Thanks for watching.